Isabella, 1 meter.
They don't want me to either. So why are you lost all the time? That's great. I was lost with
Sorry, did I say just now I missed you guys? No.
I don't know why you were missed us. Sorry about
Stop breathing and put your mask on. Did you not miss us? Did you not miss school? Really? Well, why don't you stay home and do online? Okay, everybody sit down. Okay. All right. Okay, so now we're going to talk about how the nervous system actually communicates and works. And it goes like this. So something will happen in the environment that is sensed by a sense organ in the organism. That change in the environment that can be sensed is called a stimulus. So if I shout at Isabella, the stimulus is a sound wave. Okay, it's a sound wave. That then is perceived by her ear. So there's a part in her inner ear that is sensitive to that sound wave, and that will pick it up. That then sends an impulse. That's an electrical change in a neuron. Tony!
Oh, my children.
Okay, right. That sends, so the receptor or sense organ, which is Isabella's ear, sends an impulse as an electrical structure via a neuron to the central nervous system. And in this case, it'll go to the brain. It'll go to a specific part of the brain that interprets that impulse as a sensation of hearing. Okay. The brain then processes the information. Okay? So Isabella's brain goes, Paige shouted at me and told me to stop doing what I'm doing. Okay? And that part of the brain then decides what must happen as a response of that. So knowing Isabella, it will go to which part of her body?
No.
Her mouth, and she will go, you. No, her. Whatever. You know Isabella, she's not really a cooperative child. Okay. So the brain then sends an impulse, which again goes via a nerve, to what is called an effector. And this is a muscle or a gland. In Isabella's case, it will be her jaw muscles and her tongue muscle and her muscles between her ribs, which will push up air, and Isabella will just say, ma'am, I don't care. I'm not going to do what you tell me to do. So that is a response. Is it Isabella saying rude things? Is her response.
This all happens in like 0.2 seconds.
Yes. Yes. Because you're so used to doing that.
No.
But you don't have to stop and think about it. Is it a sensible thing to do to tell Mrs. Page I don't care? No, it isn't. I will just tell her. So you're all happy about the different parts of the nervous system. So there will be a stimulus. That then will be picked up by a receptor. So the eyes, the ears, the skin, etc. So there are a number of different receptors. Okay, those are the sense organs. That receptor will send an impulse through nerves to the central nervous system. The central nervous system will process. That central nervous system then sends an impulse again through nerves to an effector organ, and an effector organ is a muscle or a gland. And as a result, there will be a response. Okay, and that's how the entire nervous system works. So we're first of all going to talk about the structure of nerves and nerve cells. Then we're going to talk about the structure of the brain and then the spinal cord. And then we're going to deal with the receptors. We're only going to deal with the eye, unless we've got enough time, and then we'll deal with the structure of the ear. But we will probably only deal with the structure of the eye. Okay, we're not going to do any of the rest of the receptors. Okay, happy. Do you remember you learned last year about nerves and neurons?
Yeah.
Okay, so let's just have a look. Central nervous system consists of two parts. The brain and the spinal cord. But then there are nerves which go from receptors to the brain or spinal cord, and there are nerves which transmit impulses from the brain and spinal cord to effector organs. Now, neurons are one-way streets. So if one looks at different neurons, there are neurons which are able to transmit an impulse from a sense organ to the central nervous system. Different neurons transmit impulses from the central nervous system to effector organs. Because neurons can only transmit impulses in one direction. They can't transmit them in both directions. So some neurons transmit impulses to the central nervous system. Different neurons transmit impulses to the effector organs. They can be part of the same nerve, but they're separate neurons. So it's like a two-way street. You drive out into whatever this is, Maple Street in the front here. It's got a lane which goes in that direction, and it's got a lane which goes in that direction, but they're part of the same road. Now, it's exactly the same with nerves. Nerves are a bundle of neurons, and they will always, unless it's a really, really tiny nerve, there will be neurons which transmit impulses to the central nervous system, and there will be different neurons which transmit impulses away from the central nervous system towards a receptor organ, an effector organ. Okay, somebody had a half a hand.
Does mean that I already answered my question?
Okay, you're right.
Now, does everything that's in the PowerPoint on the booklet?
On the?
Booklet.
Yes. Okay. All right. But I have put the PowerPoint for you on Google Class. Okay. All right. So the nerves form what is called the peripheral nervous system. So the nerves that transmit impulses from sense organs towards the central nervous system, and from the central nervous system to effector organs, that is called the peripheral nervous system. You guys happy with this word peripheral? Okay. Yes. You know what it means?
Like peripheral vision, like side.
Okay. All right. So the peripheral nervous system consists of sense organs, and from those sense organs, remember that sense organs are also called receptors. From those sense organs, nerves transmit impulses towards the central nervous system. The central nervous system is also made of neurons. We'll talk about that later on. And then nerves transmit impulses from the central nervous system towards an effector organ. And an effector organ, remember, would be a muscle or a gland. Okay, you happy with that? So the central nervous system, brain and spinal cord. There's never a nerve which goes directly from a sense organ to a muscle or gland and bypasses the central nervous system. It's just not feasible. It just doesn't happen. It'll always go a sense organ, nerve, to the central nervous system, which then processes that information and sends an impulse via a different nerve to an effector organ. Okay, right, you happy with that? Okay, blah blah. Okay. So we're going to quickly look at neurons, being a revision of work covered in grade 10. And neurons, remember, are the functional units of the nervous system. In other words, they're the cells of the nervous system. Yes, Papa?
Now we need to know this for this year.
Yeah.
Or will we need to know absolutely everything or just certain?
Just what's in the PowerPoint and in the notes,
Okay, thank you.
which probably includes everything. Okay. Yeah.
Just out of curiosity, I heard there's a condition that people have, some people have that have like, they don't have feeling, like they can't feel pain, but they also, I don't think they can feel anything. How does their nervous system work? Do they just, is it
Badly.
Yeah, is it just like, is it a,
No idea.
so it still exists, but it just doesn't transmit impulses. So,
It must transmit certain impulses because they're like able to move. And they're able to move their mouths and they can see and whatever. It just appears as the impulses which are transmitted concerning things like pain and that kind of stuff don't happen. Tony?
I just need a file. That's it. Leave your recipes open, sis.
So then the reason, so just as a person, so then if you, like, let's say you lose feeling in your hand.
What are you wishing on me?
Let's say some individual loses feeling in that individual's hand, but that person can still feel, or that person can still move their hand. That means that the transmissions to the hand don't work. Or they do work, but the transmissions out of the hand, because when they touch something, they can't feel it. Science, so they don't. That
Oh my
I thought they warned us before they do that.
Apparently not. I think that was the first part. I know what this is.
So, yeah, so the nerves, it could be that the nerves which transmit impulses from here to the central nervous system don't work.
Yeah.
And if those nerves don't work, then there would be no feeling. Because you know that the feeling doesn't happen here, the feeling happens here.
Yeah. But then you can still move it, so then from there to there.
Yes, but remember I told you they were separate neurons? They transmit impulses from the central nervous system to the muscles that respond. Those would still be working. Okay.
Oh my gosh, that's why I love when I get up in the morning.
Is it? Sorry guys, I just need to set something up for the matric test.
What happened? For example, I don't think it's coming to the mosque.
Say again?
What happens if there's, I think it's people with Tourette's, that their body, I think it's Tourette's.
Yeah,
It's invisible. They just like this, they go like this and this. Like one person, like you look like the entire body, they'd be swearing, their body would be jerking, grabbing things like that. How does that work? it's a synapse misfire, right? It's like your brain. You don't know, just now. What? No.
I have to tell you the following. In order to teach history, you go to varsity, you do one course in history 1, maybe history 2, maybe history 3. 3 subjects, 3 courses.
Yeah.
To do biology, you've got to do physics, you've got to do chemistry, you've got to do biochem, you've got to do virology, you've got to do microbiology, you've got to do plant physiology, you've got to do whatever. And kids go, what's this little red dot on my hand? And then, what's that tree over there? No, it's just not possible. I do far more work than any other teacher in any other subject. Just appreciate that I don't know everything.
So, I don't know experience, but I don't know if you know, but if you don't, it's okay.
Thank you, Emily. I appreciate that response as opposed to, what? Are you earning a salary?
Shape, like, and can't help it. What is that? What impulse is that?
Man doesn't know.
Like for crafting. Okay, I tell you what, I'll stay up all night tonight researching this work. And I will let you know tomorrow. Or maybe I won't. So I don't care.
Man, how do you apply the same logic? Like you said, I went through all these courses and some kid asked me why is there a red dot on my hand? Can we say that exact same thing in a test? Like if you be like, oh, here's an extract on this, and it's like, why does this happen? It's like, well, it's there. Can we do that?
Yes, and then I can do, well, here's your 0. Right here.
No one time.
My mom used to.
For mom, what?
My mother used to do that.
What?
Because she used to teach me in grade 7, man. And if I didn't hand in work on like finals and that, she'd be like, so just slide a 0. Oh, wow.
Okay, sorry, my angel.
Oh no, Emma told me she could research that.
You're right.
I've been surpassed by Google. What did Google say, darling?
That lots of nerve cells in the brain.
Pardon?
The lots of nerve cells in the brain.
You look so composed too, like you're spilling the tea, that's funny.
Let's go.
Right. Okay, go. Alright. So remember that you learned last year, neurons are very long, very thin cells that transmit electrical impulses, and they can be exceptionally long. So if you consider a giraffe, for example, can have one neuron which runs from the bottom of the giraffe's leg all the way up to the spinal cord. That's a single very long neuron. So neurons are very, very, very long cells, far longer than any other cells. Although there are short neurons, it's possible to have certain neurons that are exceptionally long. Okay, Tony.
Man, let's say a person like came to a giraffe, this is going to sound terrible, and just cut that nerve. Would they like lose nerve feeling in their neck and their leg? Or would it just be like that?
It depends on how much of the nerve is actually cut.
In half. It's in half. It's gone.
No, it depends on, in terms of where is that nerve a big nerve that has got neurons from all parts of the leg, or just that little neuron that came from the bottom of the leg.
That one from the leg to the neck.
Mm-hmm.
That one just sliced it in half.
Okay, then that little part, any impulses that came from that little part of the leg, because remember that if you consider your hand, there are lots of different neurons from all the different parts of the hand which collect together and form one nerve made of many neurons, each of which came from a different part of the hand together to go to the spinal cord, to go to the brain. So it depends on where you cut it. You cut it here where it was just one neuron, then that tiny little piece wouldn't have feeling. Or do you cut it further up, in which case all of this part
But
wouldn't
it's not
happen.
like just one big thick nerve all the way, these joining nerves.
It's nerves that join.
It's a big man.
Okay, all right. Okay, well, that's not very big, is it?
Ma'am, can you like see the nerves, the neurons? Like if you have to see a body or like does it?
No. So you can see a bundle of neurons, but each individual neuron is too small to see with the naked eye, too thin to see with the naked eye. But when there's a whole bundle of them, then it's big enough to see with the naked eye. Okay. All right. So remember you learned last year that a neuron Let's go. Okay. Each neuron is made up of 3 parts. So if you remember from what you did last year, Nats, did you do this last year? Okay. All right. So, looking at the picture of a neuron here, a typical neuron, although not all neurons have exactly the same structure. Remember that a neuron has a part that contains the nucleus, and that is called the cell body. Then transmitting impulses in towards the cell body are dendrites. Okay? So tiny little, they're called processes, but they actually don't mean something that happens, they mean a little physical thing. Little processes called dendrites join together, and then lead into the cell body. So they will transmit impulses towards the cell body. The cell body then sends an impulse out. The impulse carries on going out through the axon. Okay? So there's the axon there. It's a long process that leaves the cell body, and the axon passes out of the cell body and either connects to another neuron in the sequence, or if it's right at the end of the sequence, as this neuron is here, it will connect to, in this case, a muscle fiber. Okay? You happy with that? Okay. If it was at the end of the sequence, it could either connect to a muscle fiber or it could connect to a gland. Because remember I said to you, effectors are muscles or glands. Okay. So remember that the 3 parts of a neuron are the dendrites, which are short branched extensions of a nerve cell, and along which the impulses are received from other cells at places called synapses, and we're going to talk about synapses just now. So this then, an impulse would pass from here into the dendrite, into the cell body, out the axon, and either go to another neuron or it would go to a muscle or a gland. You happy with that?
Yes.
Good. The cell body. So the cell body is the spherical part of the neuron that contains the nucleus, and it connects, the dendrites all connect to the cell body, and the dendrites then bring information in towards the cell body. The axon leaves the cell body, and the axon is a long, slender projection of a nerve cell or a neuron, and it transmits impulses away from the cell body, either towards the central nervous system or towards a muscle or a gland. Okay, but basically in the long term it will be towards a muscle or a gland. At the end of the axon branches into what are called either telodendria or, deal with this. So, somebody put sanitizer on my hand the other day and I wanted to smell it, so I went on the face shield. 2 big hand marks. Okay, telodendria or terminal branches. So if your label line goes to 1, it's a terminal branch. And then right at the end, there's a little swelling. And that little swelling is called a synaptic knob. Okay, So what you have to know here is you have to know dendrites, cell body, axon, terminal branches, synaptic knob. Okay, happy with that?
And this is the end of an axon.
What now?
Is this the end of an axon or a dendron?
This is a whole neuron.
Yeah, but where is the terminal branch now?
At the end of an axon.
End of the axon.
Yeah. So this would be an axon. That would be the cell body. And these things would be the dendrites. Okay, and we'll start tomorrow talking about Schwann cells. Right, guys. Yes.
Mom, do you want a tissue?
Okay, so did I not send you a thing earlier on? Okay, so there will be no tissues or toilet paper that you tear off a toilet roll or using my paper towel. You have to bring your own tissues. Otherwise, you guys are going to be touching stuff that other people have touched. So I'm fine with you to take a piece of paper towel today, but you must bring your own tissues. Okay. Right, Isabella, thank you for switching off the...
My pleasure.
Because, yes.
Cards.
Yes.